Okay, now we're going to learn how to predict the products for combustion reactions, which are a type of redox reaction. You don't have to worry about knowing what a redox reaction for our purposes, but a combustion reaction is a reaction of a substance with oxygen gas to give us one or more oxygen-containing compounds. And we've seen an example of this when we were balancing chemical equations, how octane reacts with oxygen gas to give us carbon dioxide and water. And this process is very, very exothermic, and it releases a lot of heat or energy, as we've learned. And this energy is used to power our cars in an engine. But not all combustion reactions yield both water and carbon dioxide, because if you had solid carbon react with oxygen, you're going to get carbon dioxide. If you don't have H, how are you going to get water if you don't have hydrogen? Same thing here. We can have hydrogen gas react with oxygen gas to give us water only. We will not get carbon dioxide because we don't have carbon here. Okay? And this here reaction is actually very important in rocket propulsion systems. It's used as rocket fuel. And it's very important because all what the fuel combustion gives us is water, as opposed to the hydrocarbons that we get from fossil fuels. But this is much easier written on paper than it is done in actual life. Okay, let's practice writing balanced equation for combustion of liquid methyl alcohol, which has the chemical formula CH3OH. It's also known as methanol. And a little bit of an interesting story about methanol is that during the Prohibition era, the United States banned people from drinking alcohol. And alcohol does not have methanol in it. It has a compound known as ethanol, and it's a little bit different. It has CH3CH2OH structure, and methanol is one of the few alcohols that is tolerated by the human system. But methanol here is actually poisonous. It messes with the optic nerve. And so during the Prohibition era, people were moonshining. They were making their own liquor, and they were using methanol. And those people that used methanol and ingested it end up becoming blind. And so that's where we get the term blind drunk from. But anywho, let us balance this equation. So we know that we have ethanol or methyl alcohol reacting with oxygen gas because this is a combustion reaction. And since we have all the proper ingredients, we have carbon, we have hydrogen, and we have oxygen, we're going to make carbon dioxide gas and water in gas form. And these are in gas form because this is a highly exothermic reaction. You know that alcohol is very flammable, whether it's ethanol or methanol. And so our products are going to be in their gaseous form. All right, now let's balance this. And we have one carbon on the left and we have one carbon on the right. We have 3 hydrogens here and 1 here, so that's 4 hydrogens, but we only have 2 here. So let's put a coefficient of 2 to make that 4. All right, now we want to balance our oxygens. We have 1 oxygen here and 1 here, so that's 3 oxygens. Here we have 2 here and 2 here, so that's 4 oxygens. It looks like we need 1 more oxygen on the left side to balance things out. So if I put a 3/2 here, or 3/2, remember, is equal to 1.5. So 1.5 times 2 is 3, right? And then we have this one, so there you go. That gives us 4 oxygens. But we don't want to have fractions in our equation, so we're going to multiply this whole thing by 2 to get rid of the fraction. So then we end up with 2 CH3OH with combined with 3 oxygen gas to give us 2 carbon dioxides and 4 because don't forget there's already a coefficient here. So 4 water. And that is our final balanced equation. Okay, now give this a try. Write a balanced equation for the combustion of liquid pentane, a component of gasoline. So we've talked about octane. Octane, remember, had 8 carbons. Pentane has 5 carbons. So these are all hydrocarbons that we get from fossil fuels, and we use them in gasoline to give us energy in an exothermic reaction. Okay, so since we said it's a combustion reaction, so we have our pentane here reacting with oxygen gas. We know that because it's a combustion reaction. Now we have carbon, we have hydrogen, and we have oxygen. So we're going to have carbon dioxide and water. No question about it. Okay? Now let's go ahead and balance. We have 5 carbons on the left and 1 on the right, so we're going to go ahead and put a 5 here. We have 12 hydrogens on the left and 2 on the right, so we're going to put a 6 here to make that 12 hydrogens. Now let's count our oxygens. Here we have 10 oxygens, and here we have 6. So that gives us 16 oxygens. Okay? To here we have 2. So what are we going to put? We're going to put an 8 here because 8 times 2 is 16. And so we will have 16 oxygens on this side. So our final balanced equation will be like so.